Let's spend a few minutes going through some of these vector fields in Maple, and I'm going to whip through a little bit in Mathematica. Now, here in Maple, here's your basic vector field command. But first, as usual, Maple, we need to set some stuff. So I went ahead and set some parameters here with plots, with student vector. I set some options. Now let's jump back down to that one we're just looking at, because there are several here that we're going to take a look at. So let's look at this particular vector field that I worked up by hand a little bit earlier. This is where x equals x and y is 0. So let's take a look at what this vector field actually looks like. And you can see what's happening is as I'm close to the y-axis, these vectors are very small and they're getting bigger and bigger and bigger. I'm going to change this view. Let's see here. I'm going to make this like a negative. Let's see what happens if I go to negative 10. Yeah, we can see the smaller ones go away because they're scaling it, but the bigger ones are still, you can see that they're getting bigger. Now, something you may notice here, I'm going to go back to negative 2. If you look at these are not scaled correctly, because the x value should be the value of x. See, when I'm at 6, this tail is roughly at 6 right here, right? This should be going clear to 12, but it's not. What happens on these computers is when they generate these vector fields, they make them proportional so you can see what's going on, but the size of these vectors are not the true size of the vectors that you're dealing with. Looking at the same vector here in Mathematica, here's a command from Mathematica. And again, we're seeing these vectors are getting longer, longer, longer as they go out. And this color function hue is what's giving me these wacky colors here. I just decided to throw something in for the heck of it. But there's a slightly bigger look at it. You can tell clearly that these vectors are in fact getting bigger and bigger and bigger as we go farther and farther and farther. Let's take a look at this one now, where this is what appear to be those concentric circles. And that's exactly what appears to be happening. See, if I take this radius out, these do in fact appear to be orthogonal. And you see they're getting bigger and bigger as I go farther and farther away. And this same one in Mathematica, you can tell these are getting bigger, and there's definitely the circular pattern here. And I'm going to add to it a quick command to reduce the number of points of vectors that's going to draw, so I can get a little bit better look at it. And you can see that clearly these vectors are getting much, much bigger as we're getting farther and farther away from the origin. And they do, if you look at the origin, they do appear to be orthogonal, as we said they were. And let's take a look at this one. There's a bunch going on here. This is the Newton's universal gravitational constant thing. And what I did is I put it in M, and G, and I put it in on component form so you can see that this really is the formula that Newton gave us. And then what I did is I just took M, and G and made them all equal to 1, because it is just simply a scaling constant here, so I wasn't too worried about it in terms of trying to get the effect of what's going on. So let's take a look at it. And this is what Maple brought up. And you can see these vectors are definitely, the closer they are to the origin, to the center, the bigger they are. And as you get farther and farther out here in 3 space, these vectors are getting smaller and smaller and smaller, but they are all pointing in toward the center. So this is suggesting that as the two bodies get closer together, the gravitational force between them, or attraction force between them, is greater. As you get farther and farther and farther away, obviously, or as you may suspect, the gravitational force becomes less and less. And last but not least, here's the same setup with Mathematica. And we're seeing the exact same thing. Let me make this just a tad bit bigger here. What we're clearly seeing is that these vectors that are near the center are much larger than the ones that are farther and farther and farther away. So it is exactly the same thing that we just saw in Maple.